So the James Webb Space Telescope is really a technological marvel. It was 7 years late and it was $5 billion over budget, but it's up there now and we are all thankful. Slide, there we go. It was finally launched December 25th, so it was a great Christmas present for everybody. And on its way to L2, Lagrange 2, and I'll talk about that a little bit later, it had to unfold. It was way too big to be sent up in one piece, so it had to be all folded origami-like to go into the rocket. Now, James Webb is going to look at infrared or heat light, and possibly we'll get back to be able to see only 100 million years after the Big Bang. And this was the time of the first stars and galaxies that were formed. So here we have a look at James Webb. It has because it's looking at heat, the telescope and all the instruments have to be kept very, very cold. So we have a cold side here, which includes the mirrors and the instruments back here. A warm side on this side, that side's going to be facing the sun. So to transverse from that hot to cold side, it has this sun shield. So the primary mirror is made out of 18 segments with a diameter of about 6.5 meters. The secondary mirror is also made out of a similar thing. They're made out of beryllium. There we go. They're made out of beryllium, which is very stiff but lightweight, and it can maintain a stable shape even at extremely low temperatures. And it is covered in a thin layer of gold because, again, we want to look at infrared light, and gold is really good at reflecting that. Its operating temperature is going to be minus 213 degrees Celsius, which is just 60 degrees over absolute zero. There we go. The sun shield, so this whole telescope is just huge. The sun shield is about the size of a tennis court, and again in 5 layers. The material is really gossamer polymer membranes coated with aluminum, and it acts kind of like a radiator. So the maximum temperature on the hot side will be up about 125 degrees Celsius, and it cools as it goes down. So the cold side can be at a minimum of about 100 or minus 235 degrees Celsius. So that's amazing to lose that much heat over just that little amount of space.
That's so many problems that they had to solve. That's great.
Oh, never even encountered before. And it all worked, which is just amazing.
Wow.
So there are 4 main instruments on the that it will be using. They're all some sort of variation of cameras and spectroscopy, which means just breaking down the light and looking at any patterns that you see in there. The interesting one is this fine guidance system and near infrared imager and slitless spectrograph. That is Canada's contribution to this whole thing. And because we are a contributor to this space telescope, we actually get quite a bit of time. I think this was 3% of the budget, and we get something between 5 and 10% of the viewing time. So that's the fine guidance system is absolutely crucial because that's what's going to be able to keep the telescope pointed at whatever object it wants. So the photons that it gathers will all be in focus. So yeah, it's a pretty heavy burden on Canada's shoulders to do that. So again, It's going to be at Lagrange 2, which is out past the Earth by about 1.5 million kilometers out past the Earth. And as I said, it had to unfold. It took about 29 days to get there. So all this stuff had to happen. It had to happen perfectly on its way out there. And amazingly, everything did. It was something like 300 technical little points of failure, but everything worked wonderfully. And it started cooling as it went down there. I mentioned the Lagrange points. Let's see if there's anything else I need to talk to you about that. Okay, no. So the Lagrange points, when you ever have two bodies in space, so here we have the sun and the Earth, and of course the Earth orbits the sun. And this sets up 5 gravitational areas that are sort of where the gravity of each cancels out. And they were found by this fellow named Lagrange, so that's why they're called Lagrange points. There's one in between the Earth and the sun. There's one, the L2 point where Webb will be, is like I say, 1.5 million kilometers away. And then there are 3 other ones, one on the opposite side of the sun, and then 2 that go ahead and behind the sun. And I really like this way of showing gravity because it's like a topographical map. It shows how the sun's gravity weakens as it gets out, as does Earth, and its interaction. And I just found this really cool animation to show it. So here we have the sun in the center, and it's kind of showing the well of gravitational well. And it's also showing the Earth orbiting and how these 5 points move in relation to the Earth. So Lagrange 2 is here on the opposite the Earth from the sun, and it will follow Earth around as it orbits. Here's another sort of animation. We have the sun in the middle, Earth's orbit, and this huge Lagrange area that Webb is going to. Lagrange, these areas are picked, like I say, the gravity kind of cancels each other out. And so it's really easy to stay there with using minimal amount of fuel. This is quite a big area in space. It's got about a 500, oh, I'm gonna mess that up. I won't say it. It's millions of kilometers across. So it's got a lot of space out there. The Gaia spaceship, our space probe, it was measuring distances and a bunch of other stuff to stars. It's parked there also. It's a very popular place. So more and more things will be parked out there.
Have we sent probes to the other Lagranges, like to 3 or 4, like to know that they also don't have?
Not yet.
Not yet.
No, not yet. There is a probe going to the Lagrange points, like 4 and 5, that are set up Jupiter's Lagrange points, because there's a collection of asteroids at each of those parts. It's Lucy and I can't remember the other name. They're on their way there. So they'll be looking at the asteroids that sort of contained by Jupiter, which is kind of cool.
Neat.
I'm going to go back so this slide will start again. So this is how the whole thing had to unfold. Here comes the sun shields. Remember, these are really fine gossamer sheets of an aluminum. They had to be pulled out. You can see that happening here, extended on both sides. And then there was 5 layers, and then they had to be separated. This was probably the scariest part of the whole thing, because these had to go perfectly. And that alone had something like 175 points of failure as these things separated and then were pulled taut, and everything worked. So So once those are out there, then the secondary mirror can come down. Come on, secondary mirror. There we go, on a kind of a tripod, and the wings of the main mirror came out. So as of yesterday, here are the temperatures of James Webb. You can see on the hot side, we're looking at about 53 degrees Celsius. So this is the hot side here, part facing the sun, which is great because that's where the solar panels are. So it will run off electricity. And the cold side here where the telescope is, we can see that some of the areas are down to, well, this one's down to minus 224. Excuse me. I visited my grandson at Christmas and promptly got a cold. That is lasting and lasting. So I have a hulk in my mouth, so it might feel kind of garbled, sound kind of garbled. Anyway, so we're getting down there so that the fine guidance system, the one that Canada was responsible for, operates or needs to be cooler than this, but it's already at minus 224, which is just amazing. It's only been there for a little over a month. So space is really, really cold unless you're looking at the sun. Oh, and I forgot to mention, on February 3rd, it captured its first photon. The light traveled through the entire telescope and was detected by the near infrared camera, one of those 4 instruments. And this is really a milestone because it marks the first of many, many steps to capture unfocused images that will be used to fine tune the telescope. It's going to be looking at one unremarkable star, and it has to align all those 18 mirror segments so that all their light is focused in sync on the secondary mirror so that it can then go back to the instrument group. So it's already doing some, not really science, but it's working. And it's going to take 2 months to fine tune all those 18 segments. So we still have about 5 months to wait for any science to begin and to hear any results. So what the James Webb is going to be looking at, the very early universe, like 100 million years after the Big Bang. So it's going to you got the first stars and galaxy that formed. It's going to observe different galaxies and black holes and see how they form and evolve. It's going to look at the life cycle of stars from their birth to their death. Stars are born in huge clouds of dust and gas, depending on how much fuel they get. Hydrogen depends on the length of their lifetime, and it depends on how they die. So it's going to be adding in some of the things we're not quite sure about in stellar evolution. It's going to examine planetary systems, including our own, and look at how they form and evolve. We thought all planetary systems, once we found them, should look very similar to ours with 4 rocky planets, 4 gas giants. Turns out that we are one of the few systems that look like that, although that could be observational bias because it's easier to see the oddballs than it is to see systems like us. And we can go into that later if we want to. The really exciting thing that I'm finding really exciting, it's also going to look at the atmospheres of exoplanets. So exoplanets going around other stars. When it transits the star, or comes between the star and Earth, that starlight will go through any atmosphere that planet might have. And using spectroscopy, we can determine what molecules and elements are in that atmosphere. So I've talked about the electromagnetic spectrum before. To an astronomer, the electromagnetic spectrum is light. It goes all from gamma rays through X-ray, ultraviolet, the visible or optical portion, infrared, microwaves, and radio waves. So these are all different forms of light. We can learn different things looking at each one. There have been telescopes that have looked at each of these. The Hubble Space Telescope primarily looked at the visible wavelength, the ones that we can see with our eyes, did a little bit in the ultraviolet and a little bit in the infrared. The James Webb is going to fill in this large portion of the infrared spectrum. And Spitzer, which has already been, I think it's just been decommissioned too. It ran out of the cryogenics to keep its instruments cool enough. It did the far infrared. So James Webb's going to fill in a lot of the stuff we don't know. And in that atmosphere, if we see that the exoplanet atmosphere, this is what a typical spectroscopy graph looks like. So we're looking at the different wavelengths, and we're looking at the amount of light that is coming through them. And it's like those UPC codes you see on all product packaging. Each element, each molecule has a specific wavelength where it will absorb light, several wavelengths actually. So we can see James Webb will be able to tell if there's oxygen in that atmosphere, and water at several different wavelengths, methane at several different wavelengths, and ozone and carbon dioxide. If we see all of this in an exoplanet's atmosphere, we're pretty sure that that means there is some sort of life on that exoplanet. And that's just going to be mind-blowing to actually confirm that there are other planets out there which have everything conducive to light and products that are produced by light, especially the oxygen. So oxygen is really reactive. So to have a large portion of oxygen in an atmosphere means that it has to be continually replaced. And the only thing we know that can do that in those kind of quantities is life. So I'm really excited for that. So why look in infrared? So I'm just going to show you a few of the Hubble pictures taken in optical light, like this one. This is the Pillars of Creation, compared to what Hubble saw in infrared. So these are amazing things. They're about 4 light years long. And we can see that there's several stars around. We can see also some starlight kind of leaking out of these huge dust clouds. So we know that there are stars in there. So this is what Hubble saw in the visible, and this is what Hubble saw in the infrared. Look how many just times over stars that we see, because most of the stars in the universe are cold and just warm and small. They don't emit a lot of light. And we can actually look through the clouds here and see the stars that are being born at that moment in planetary systems and things like this.
Wow.
Here's another one, the Lagoon Nebula. This is a great observing object for the summertime. It's in the constellation Sagittarius. So we see it's a huge gas and dust forming and star forming area. Again, this is in Hubble visible and Hubble infrared. Look at the number of stars we see there. We can peer down and see the stars just being born. The Karina Nebula is a favorite of astronomers. Again, this huge dust cloud, gas and dust, and we can see that there's activity going on. We see this light kind of streaming out of it. So in visible light and in ultraviolet light. And we can see now, it's not this star with the spikes, that's a foreground star, but we can see that there's a star. It's a massive star, maybe 200 to 300 times the size of our sun. and it's in its process of blowing off a lot of its gas and dust as it falls onto the star. Big stars, well, even our star, they have magnetic fields, and when stuff falls onto the star, sometimes it gets caught in those magnetic fields and gets put out in these jets. So, you know, no idea what's inside there. And here we can see a star and its jets. And of course, all the other stars that are out there. So I mentioned we'll be able to look back farther into closer to the Big Bang than ever before. Ground-based observatories in like the 1990s could only go back to about 6 billion years after the Big Bang. The Hubble deep fields and the increasingly deep fields got to about 500 million years after the Big Bang. And the James Webb is going to be able to look right back to maybe 100 million years after the Big Bang, right when the first stars and galaxies were forming, which is really, really exciting also. Now, originally it was hoped that the James Webb would last for 5 years, maybe 10 if we could stretch it. But the Ariane rocket, which was the European Space Agency contribution to this project, was so exact in its timing that the telescope will only needed minimal course changes on its way to L2. And now they have figured out that it'll probably last at least 20 years before the fuel runs out. And once the fuel runs out, then it won't be able to keep as good pointing and in that Lagrange point steady enough. So 20 years from originally thinking it was going to be 5. That I can't even imagine what discoveries that's going to be. And like most new technology in astronomy, we find that the most amazing discoveries are the things we don't even know we're going to find out about yet. They're the questions that have not even been asked about yet. So I was going to go into some of the NASA spin-offs of the James Webb, and I started looking at it. They've just put out a 47-page PDF about all the spin-offs. So I'm going to have to do that some other time. But needless to say that there is nothing in your life that has not been touched by something that NASA has done. Even the JPEGs on your phone, those were developed so that the pictures coming down from the Voyager 1 spacecraft in the 1970s from Jupiter, that they could come down. So everything of your life is touched by NASA and its technology. So some other exciting things that are going on in astronomy right now. As of yesterday, we know of 4,914 confirmed exoplanets. That's planets, again, around other stars. Most of them are within about 1,000 light years of our sun, our Earth, so fairly close. And it's looking like most stars do have at least one planet and some multiple planets. Kind of sad news. NASA plans to use and actually has commitment for funding for the International Space Station until 2030. And then they are going to deorbit it in January of 2031. They figure by that time they'll transition to the commercially owned and operated low Earth orbit destinations. There's lots of commercial companies that are planning on doing low Earth orbit things. Space Station is running its course. So it will, as of now, it is planned to be deorbited, which will be an amazing sight. It'll probably end up in the Pacific Ocean somewhere. The Artemis 1, this is returning humans to the moon mission. They keep saying they're going forward. The they have the whole thing assembled now with the Orion capsule on top, and it will be moving out to launch pad 39B no sooner than March for testing. Again, like everything else with Artemis, that's a little bit later than they originally planned. And once it gets out there, it'll do a wet dress rehearsal. So it'll be loaded with propellant and it'll go through a complete run through of the pre-launch operations, possibly, and prepare for possible Artemis 1 launch, maybe by the end of March. I'm not going to hold my breath, but possibly. Artemis 1 will launch, go around the Earth, fire its rockets for a translunar injection. On its way, it's going to let out some of CubeSats. These are tiny kind of shoebox satellites. Private companies, individual scientists have sent them. I don't know exactly what each one's going to be holding or doing. Then it'll go into the moon's gravity and be caught by the moon's gravitational field. And it's going to go much farther. It's going to go about 460,000 kilometers from Earth. Now, the moon average distance is about 384,000 kilometers. So it's going to go quite a ways past the moon and go into an retrograde or opposite orbit. So the Earth is spinning this way, the moon is spinning this way. This orbit is going to be opposite that. And it'll orbit that for about 6 days. It's going to be, at one point of that orbit is about 70,000 kilometers from the moon. Used with all the other moon shots we've done, kind of circular orbits very close to the moon. This one's going to be elongated and quite different. And it's going to be spend at least 6 days there, and then come back and again splash into the usually the Pacific Ocean. Oh no, this one's coming back in Florida, I think. I can't remember that. Anyway, it's going to be about a total 4 to 6 week mission. And like I say, scheduled possibly for the end of March, but we will wait and see. There are lots of private space companies coming up. This is from the Axiom mission 1. These are the crew members that were just picked up. Now, Axiom is a private space company. However, they're going to send these guys to the ISS on a SpaceX Falcon 9 rocket and in the SpaceX Crew Dragon Endeavour. They'll go up for about 10 days to the space station and do some private space station stuff. I'm not sure what they are. The interesting thing is this guy is a Canadian, Mark Pathy. So Canada is being well represented in all these private ventures. Some news on the Ingenuity and Perseverance, who they're on Mars at the moment. So Ingenuity is this cute little helicopter that they sent up. It's done 19 flights so far. They were hoping to get 1 or 2. It just keeps going, for a total flight distance of almost 4 kilometers. Perseverance has driven just over 3 kilometers, and it has collected 5 sample tubes. So it goes out and it drills holes, and it's storing these sample tubes for further retrieval. I'll get into that in the next slide. Perseverance can self-drive. NASA tells it where it wants to go, and it can kind of figure out its way to get there. So it can do 200, 250 meters in a day, where Spirit and Opportunity we're doing only a couple meters a day. So this is great. It's being able to really explore the surface of Mars. So I mentioned the sample tubes. It's hoping to get 43 sample tubes altogether, some with gas, some with soil. and these will hopefully eventually get back to Earth. So that is coming with the Mars Sample Return Campaign. So it's the first leg of it. There are 2 sample return missions. The first one would land somewhere near where Perseverance is and either go out and collect the samples itself with a little mini rover, or have Perseverance deliver the samples near it. And the first contract has just been made to, oh, I forget what company it is, might be in my next slide, for the rocket. Yes, on my next slide, here we go. So hopefully this will be going up in the mid 2020s. So the rocket has just been awarded to Lockheed Martin. Just this little rocket alone is worth $194 million. The spacecraft is going to be a European Space Agency one. So that's going to land. Again, here we have a little rover going out, collecting these little samples, bringing them back to that rocket. Or like I say, maybe Perseverance might bring some to it. Then the rocket will blast off from Mars and meet another orbiting little satellite, which will it'll transfer the samples to this little satellite, and that satellite will then come back to Earth and send it a little capsule heading towards Earth with some of these samples. And then on Earth, we can examine these samples way better than anything on that we can send to Mars to sample. What was I going to say? Hopefully by 2030s, this will all come into play.
That's pretty wild that they have to collect it, get it off the planet, put it into a probe, into another probe, and back to Earth.
I know, yeah. Any one of those could fail and completely ruin the whole thing. When that rocket blasts off from Mars, it will be the very first rocket to blast off from another planet.
Oh,
I mean,
wow.
we've done the moon, but those were just little tiny ascent. They weren't really rockets. They were just little things to bump up. This will be an actual rocket going away from Earth. Really excited to announce that we received a grant from the Central Okanagan Foundation to buy a 3D printer. I'm putting it together right now. From this printer, I plan on doing things like the Apollo 11 landing site and craters on the moon, like the Copernicus craters. You can also do little spacecraft and stuff, and even asteroids. This is asteroid Eros, and it's just printed in showing it prints in 2 different things that you can stick together. So I'm really excited to be able to show you that. Hopefully by the time I get this all together, I'll be able to come and actually visit you and show you some of these samples. And speaking of asteroids, here we have one known as, let me move my thing here, as 10096, an asteroid about 3 astronomical units, which from the sun. So 1 astronomical unit is the distance between the sun and the Earth. This one orbits at 3 astronomical units. Takes 1,931 days to orbit the sun. Why am I excited about this one? Well, yesterday I was informed that it is now known as Colleenohare.
Nice.
I have an asteroid. Totally shocked, totally gobsmacked. You're the first people to hear about this.
Well, that's pretty cool.
I don't know what to say about that. It's just freaking amazing.
Who named it after you?
The club submitted my name. This was in 2018, and the International Astronomical Unit just came and said, yep, she can have that one.
Oh, wow.
Yeah, I know, it's 11 kilometers across. If I ever get a good render of it, I will print it up also. So anyway, that's my most exciting news for the day.
You 3D print your own meteor.
I know.
I wonder it could be an alien spaceship.
Ooh, wouldn't that be cool?
I keep reading stuff on that, what was that, Hawaiian one?
Oumuamua?
Oumuamua, yeah, and
Yeah.
that crazy professor from Harvard, or
I know. I mean, he's a highly respected professor, but he's got this one crazy idea. Anyway, I think he just needs to make money for his retirement.
yeah.
And with that, I would be happy to answer any questions.
Great.
I will stop sharing.
I'll get the lights here. I guess we don't need the lights. A little bit. Can you see us?
I can see you perfectly. Everything's working this today.
All right. Any questions, gang?
Or suggestions on things that you'd like me to talk about in future.
Yeah, we have some of those. We can go over those in a little bit here. But
Okay.
one question I'm curious about
Okay.
is we had the Hubble telescope in the one range, and then you have along the spectrum there, then you had this other telescope kind of way out there, and now we're filling in the gaps. I'm wondering how it got from just skipping that whole point and getting to that farther along the spectrum.
Yeah, that was the Spitzer Space Telescope that when that was designed and built, that's the part of the spectrum they wanted to look at. And I'm not sure exactly why that was chosen and not something, incremental reasons out. But they also have like a gamma ray telescope. There's an X-ray telescope, and they kind of not a lot in the ultraviolet. So it's just what people's projects are and what they can get money for, I guess.
Yeah. Any questions?
So for the Artemis project,
Yeah.
the rockets that are going up in like 2030 and whatever, those are going to be unmanned, right?
Artemis 1 is unmanned. Yeah, it'll just go around the moon.
Do you know when any manned rockets will be going up?
Artemis 2 will be manned, including a Canadian, which is cool. The SLS, that main rocket, this is why I'm so against the Artemis project. The SLS main rocket they figure they can only get one a year up at a cost of $2 billion. Now, SpaceX has been chosen to build part of the Gateway project, which is like the space station, only it'll go around the moon. And SpaceX has been chosen, those, I don't know if you've been watching SpaceX, their rockets are huge. And that's been chosen to get to actually land people on the moon also. So there's a lot of things there's a lot of things coming along. Of course, Jeff Bezos and Blue Origin is pissed off because SpaceX got the contract but there are other private companies that are trying to get in on this too. So what it's going to finally come down to, I'm not sure. It could just be funding too. $2 billion a year to send one rocket into space is quite a lot.
Yeah.
And I don't know when Artemis 2 is planned for, but they've got the astronauts chosen already. They are being trained, and they'll just go to the moon and around. Artemis 3 will be the landing, and it depends on how things go for NASA for that.
It's like really become just absolutely big business.
exactly. And NASA is seeing that, and that's why they're getting rid of the space station. That is a lot to keep up. So if they can, use somebody else's space station and not be responsible for the maintenance and the upkeep and the growth, and just do their science experiments, that's the way they're planning on going in the 2030s.
Huh. Yeah, I guess, yeah, in some ways it makes sense. It makes sense. But then in the other, you look at if you privatize the roads
Yeah.
and you're driving back and forth from Vernon to Kelowna.
Yeah.
Hmm.
Well, I mean, these companies all still have to prove that they are very high standards and NASA quality standards, but they just do things differently than NASA, and it just is way cheaper and apparently way better also.
That might be just something to look at too. Might be these private companies that are getting involved in what their angle is, or
Sure. I can look at that.
that'd be pretty cool. What about some other ideas, guys?
Didn't they have like something, because there was the Perseverance? I think there was like a Chinese competitor. They're not like competitor, but
Did China sent something to he's talking about China sent something to Mars or something?
Yeah, China sent a orbiter and a rover, and India sent an orbiter at the same time that NASA sent Perseverance. So that was February. That was a year ago. Yeah. China also has a space station that it's building, and it seems the Russia is going to be going with them more than just, once the space state, the ISS is lifetime is over with.
Wow.
Oh, and I have to tell you something. You know how the movies I'm not so fond of, right?
Yeah, Gravity.
Yeah, and Interstellar.
Yeah.
I just watched a wonderful video from Chris Hadfield, and he talked about those movies and some others, and he agrees with me completely.
Nice.
That some of the science was okay, but the stuff that was bad was really bad.
And you said that you read Hadfield's new book's pretty good, eh?
Yes, the new ones, the Apollo murders, are awesome. However, I did find one mistake in there also, but I won't mention that. It was only the one.
Uh-oh, did you email Chris?
No, I haven't yet. I'm sure somebody has talked to him about it. And I'm surprised it actually made it to the book. It's a pretty basic mistake.
Well, you might not listen to them. I mean, you have a meteor named after you, right? So that
That's right.
you have
I'm
some
sure he does
interstellar
also.
clout.
Oh, and something else I wanted to mention, Rob. You had asked a couple of times ago if we had a mock-up of the Hubble that we could do stuff with if there was problems, like we have a mock-up of the Perseverance, if something gets in, right?
Right.
And I said, well, I didn't think we did. Well, apparently we do. It's not a whole Hubble, it's the electrical compartment, and it's wired exactly the same way that it is on Hubble. And it's gone through all the changes too, so that because they're starting to have a few problems with Hubble, they can go and see exactly what could be causing the problem. So I thought that was pretty interesting too.
Oh, just the models, right? That's cool. Yeah.
Yeah. And apparently an engineer walked by it the other day and said, well, that's not how you should be doing this. We got better components now. And they said, don't touch it. Don't touch it. That's exactly what Hubble is running on. So
Oh, that's wild. Some other ideas, gang? What are you thinking? Newman, you said something about space travel.
Yeah, space travel,
Like-
any form, the planetary, is a bit of interest in like stellar engines and stuff, but that's like super theoretical.
yeah.
I mean, that's cool, but like kind of just any space travel, really.
Sure.
Maybe from like current tech to kind of theoretical to sci-fi. I don't know.
Have we all been watching The Expanse?
No, what is it?
Oh, it's a TV show. I think it's on Netflix now. I'm not sure.
The Expanse.
The Expanse, one of the best sci-fis ever that really kept physical constraints to things that they could do. And one of the things I always marveled at, people think you can get up in a rocket and just blast off to anywhere and just go as fast as you can and then stop. Well, that's not how it works. If you get up into space and blast off going really, really fast, halfway to whatever you're going, you have to flip and have your rocket slow you down.
Right.
And they did that on The Expanse, and that was really kind of neat to see that they looked towards that.
Is it what's the premise of it? Is it like season 1, season 2? What?
Yeah, there's 6 seasons. The premise is interplanetary space, travel, warring factions between the Earth, which is controlled by the United Nations. Mars has its own colonies and a space force. There's the belters who live on all the asteroids in the belt. It's just an amazing, and it also goes into traveling to other systems and things. It's just really, really well done.
Oh, cool. We might have to check that out. We might get
Yes.
some ideas from that. That'd be fun.
Yes.
Uh, some other ideas. What do we have, guys? Oh, the Gateway project would be cool to learn more about. Like that sounds,
Okay.
That's pretty wild. I remember we talked about it before.
Yeah. Sure, we can do that again. I'm sure there's new stuff.
What were you talking about, Cash? You were talking life forms. Yeah, Cash was interested in other life forms on other planets. That idea.
Yeah, astrobiology is one of my kind of passions.
The space station they're making. What about that?
Yeah, Jared's saying the space station in China. What's going on with that? What are they up to? How come
They have one. They have one, and they send astronauts or taikonauts, I think they're called. But I can look into what that's doing too.
how cohesive are all these different agencies going up? Is it like is it? I imagine there must be secrets.
Oh yeah. Oh yes. Secrets, and there's trying to be, people are trying to set up rules. There are some rules. We went over one a bit ago about whose space are you in, and you have to sign on to, if one station has a catastrophic failure, the other one has to be able to somehow help out. There's all these conventions. Who owns the moon? What are people allowed to do on the moon? That's a whole topic of discussion that is quite heated sometimes.
So like that would be like space laws and space.
Yeah,
rights?
yeah.
Well,
Like
even
Elon Musk has to get permission to launch all those satellites. But that seems to be pretty lax because they're going up, every other week. He's sending another bunch up there, and the sky's getting worse and worse.
And permission from whom, right? Like what governing body? Like every country on the world, or is it just
There is an international body that gives permission, but they seem to have not looked far enough ahead to see what would happen with this for astronomy. It's going to be great for internet. All over the world's going to get internet, but you won't be able to see the night sky.
Yeah, and maybe funding from SpaceX, right? That's Okay, cool. Well, we
How
got.
many failing points did the James Webb have?
Oh, how many failing points did the James Webb have?
Over 300.
There's Cash over there.
Oh my gosh, over 300.
Yeah, cool.
Like the sun shield, like I said, I think it was 178 single points of failure, but they all worked, which is one of the reason why the Webb was so overdue and so over budget. Hubble, was planned to be able to be upgraded. Well, we're never, ever, ever going to go to James Webb and fix something. So it had to have redundant systems, and it had to be tested so that we knew it would not fail.
Gang, you want to just go around and something that you found interesting or something that you learned? We'll start with Jared.
I hadn't really heard about the James Webb before. I think that's pretty interesting. I think
Yeah, that's the telescope of the future right now. So yeah, it's going to be so interesting when the science starts coming back.
I think it's kind of weird how they like kind of skipped over the infrared stuff like Rob was talking about. I think that's weird.
You know, there may be a reason that we didn't have the technology at that, during that time to capture that wavelength, those wavelengths. I really don't know why it was skipped over.
Yeah, it's a lot of it is kind of good refresher, I guess. But it's like some of the more details of like the 300 failing points and all that kind of stuff. It's like, yeah, I knew there's a lot of like intricacy and delicacy with it, but to that degree and level is really something else.
Yeah, I'm sure the people that built the James Webb did not sleep for those 29 days while it went from the Earth to L2.
No sleep and no hair.
Yeah.
That's what we want.
Sorry, I heard none of that.
Said her brain hurts and it's a bit numb and she's trying to process things.
Awesome. I've done my job.
Yeah. Yeah, one thing I kind of like the Lagrange 2 and 5 and like all
Yeah.
the Lagranges, like, and that they're around other planets. I was at the beach the other day and my kids were throwing rocks and I was kind of watching the waves and I was thinking about, as the waves were hitting, right, I was thinking about those points out in the universe, and it was just kind of cool to have that model here. And there's probably all kinds of models right here on Earth about different things that happen out in the universe, right? And I just kind of pretty wild to think about.
We are part of the universe. We're
we
no
are.
different than any other part.
Yeah, exactly. So that was and then also, like, you think about some of the things, like if they didn't figure out those signatures of like spectroscopy, like
Yeah.
how much information that science has been able to give us about the universe, and just thinking if there is there, this James Webb could be finding other things that are like spectroscopy that could be opening our eyes in the same sort of ways. It's just kind of
Basically everything we know about the universe has been from capturing light that lands on Earth and spreading it out and looking to see what's there.
yeah. Wow. Cash, how about you, buddy?
I thought it was cool.
I guess thumbs up.
Yep.
Cool, Colleen.
Okay, I have a list to work on.
Well, thank you very much. It's always yeah, amazing. Yeah, I'm kind of like Anna right now. My brain's pretty full.
Good. Okay, see you in a couple weeks, I guess.
All right, sounds good, Colleen. Thank you.
Okay,
Okay, bye-bye.
bye everyone.